Tonight's tinkering is accompanied by Irish Red Ale from Good Neighbor Brewing Company in Winnipeg. Nice simple tasting notes. They suggest notes of toffee, raisin, plum, and a light bitterness. So today I'm taking a look at this stepper motor that I ordered sometime last year and quite honestly I forgot about. What makes this one unique is that it actually has two concentric shafts, just like a clock movement does. And it is actually two stepper motors. Here is one coil and the second coil for the first motor, and one coil and the second coil for the second motor. So you should be able to control the two shafts independently of each other, which means you should be able to make a clock or something similar that does unclock-like things. So to that end, I have quickly whipped up some pointers, just a very, very quick little CAD model and about 8 minutes each on the 3D printer. So those should... Oh, I thought they went 360 degrees. They don't. They have stoppers on them. Well, that is the first bit of learning about this. Let's go and see if I can find the listing that I bought this from in a data sheet or something like that. The part number to look for is BKA30D-R5. As you can see on AliExpress, they're available from a bunch of different sellers at a bunch of different price points. Oh, and that one is slightly different too. But this or these ones are the ones that I've got. So anywhere between $3 and $14. Most of them seem to call themselves 360-degree stepper motors for Auto Instrument. Here's another one that calls itself Dual Axis Stepper Motor Universal. And another one, Biaxial Stepper Motor Rotation Motor 360 degrees. But as we saw on ours, they're not actually 360 degrees after all. I was also able to find a data sheet for them. I don't know if this is the only company that makes them, but this is a reasonable one, I think. It says it can drive two different pointers independently for dial space saving. I don't know that I've ever seen this in an automotive application, but I was thinking that it would be fun for a novelty clock that you can control. However, as we can see down here, the outer shaft is good for 320 degrees of rotation and the inner for 270. So I probably should have looked at that before I ordered it. Regardless, this is where we're at. So there is what they suggest for an application for it. And I guess that makes sense in a car dashboard. It just never occurred to me. What do we got here? 18 milliamps average current on each winding, I'm assuming. Fairly quiet, 3rd degree or 1/12th degree if you're doing micro stepping. Okay. Oh, runs between 3.5 and 10 volts. Okay, I was sort of expecting, because this claims to be an automotive device, I was expecting it to run on 12 volts, but I'll have to keep that in mind. Anyway, other than that, it is just a stepper motor, and or two stepper motors, I guess, and you can drive them the same way as you drive any stepper motor. So I guess let's play with that a little bit. Even though it's not going to be good for making a clock necessarily, you can probably still use it for something, I guess. Let's bring in my drawer of stepper drivers, and I got a couple of these. Yeah, these are some very basic, very cheap, very common stepper motor drivers, and I have used these in the past. They are also used on some older 3D printers and stuff like that. I used them for the camera above my bench that moves sometimes before I replaced it with something a little bit more high-tech. But regardless, these take an awful lot of the grunt work out of driving a stepper motor. You give them ground and power, 5 volts. You connect your two stepper motor coils over here, coil B, or coil 1 A and B, coil 2 A and B, ground, and a motor voltage, which is a separate voltage from the control voltage. And then on this side, you've got all the control pins. Direction, so Set that to high or 5 volts to go one direction, and low or 0 volts to go the other direction. And a step, which is just a clock or a pulse. I've driven it off a 555. You can also drive it off a microcontroller if you want, and I think I will just drive it with random square waves for my experiments tonight. And then you have some other control lines, a sleep and a reset line and an enable line down there. I'll have to go and look at the data sheet just to see which direction those go, but those are all not, which means they're active when they're pulled low. So it goes into sleep mode when it pulls low, it goes into reset mode when it pulls low, and it goes into enable mode when it pulls low. And then we have MS1, MS2, MS3, and those are just 3 bits of binary, essentially, to control the micro-stepping modes of these of the motor. I did a video on stepper motors years and years ago. I'll put a link to that up in the top corner, and I'll also link to this page at Circuit Digest. This one is specifically talking about using this driver with an Arduino, but it's the same no matter how you're controlling it. There is a diagram just showing how the different coils work inside the motor, and this chart talks a little bit about the microstepping. So if you got all 3 of the microstepping set low, you get a full step, which I believe these motors said is about 1.3 degrees. And these other ones you can get half step, which is half of that, or a quarter, an eighth, or a 16th step, which just puts the voltage on the coils rather than just being 100% on only one pair of coils. It gives you some proportional information around the sets of coils so that you can get partial rotations. And the driver can handle some fairly wide ranges. You can handle up to 35 volts for motor voltage on this one. As we saw in the other data sheet, 10 is our max, so I'm not going to go that high. That's for the motor voltage. For the control voltage, I saw it somewhere else. It's about 5 volts, which I'm going to run with. And the other thing is this can handle a 2 amp motor load, which is way beyond this thing. Again, I think it was in the 10s and 20s of milliamps or something, so not a big deal. And of course, it's a really cheap driver, which is why I've got a few of them kicking around. So let me grab a breadboard and start wiring these things up. It's basically going to be following what we saw on the data sheet and what I've roughly described here. Nothing fancy, so yeah, let me do this and I will get back to you in a little while. Alright, things have progressed rapidly and chaotically here. I've got 2 stepper motor drivers hooked up here. I have wires on the stepper motor itself here. I have 2 square wave generators here. I have a power supply set to 8 volts over here for the motor power. And I've got another one set to 5 volts over here for the logic power. Again, could I have done this with a microcontroller instead of all this gubbins? Yes, but I'd still need the 2 power supplies. So the 2 square wave oscillators are going into the step pins. The direction pins are these 2 blue wires here, which I can move between 5 volts and 0 volts to change the direction. The yellow wires are the microstepping wires, and I've got them set differently on... are they set differently? Hang on. Yeah, they are set differently, just so I get visibly different speeds from my square waves. And then I have the 4 motor wires there going to this motor, and the 4 motor wires here going to this motor. So, power on the 5 volts, power on the motor, and here we see them both turning. And if I move that one to that one's direction to the other voltage, and I'll do the same thing on this one to reverse it. There we go. Now then, as noted before, these are not 360-degree motors, so they will crash out eventually, which is a little annoying. So I have to keep reversing them. And I can adjust the speed of them a little bit here. This is the long one. And this is going a lot slower now. And it does have a maximum pulse speed that this thing doesn't like. I'm not sure why, but I'm just doing this roughly. I think Okay, I'm running into an end stop there, so we'll reverse them again. So, yeah, I don't know how useful this would be for a novelty clock. And it'd be fun to see a novelty clock going like that, wouldn't it? If you were to put a clock face onto it. But that's not its original purpose. And I was hoping that this one didn't have the end stops on it so that it would go 360 degrees. I think that would be better. I don't know what else I can do with this thing right now. It obviously does what it says on the tin. And I think that is kind of fun. I suppose if you just needed it for a prop to randomly display different clock faces or clock directions, that might be fun. Let's speed that guy back up a little bit more. Oops. Yeah, when it gets over about 36 hertz on there, well, let's change the stepping mode. Hang on here. Let's go high. Yeah, there it is doing full steps rather than micro steps now. So maybe I can go higher speed with that. A little bit, yeah. Looks more like a clock, doesn't it? And I could change the other one, but this is a little awkward going into the menus to change it. Regardless, we can see what it's doing. I don't know. The guy that I originally found these from, or was told about these, was using a similar one to control a prop clock in an escape room. And I guess if you wanted to be able to arbitrarily change the clock hands in your escape room clock remotely, that might be a useful thing. Although they don't both go to full 360. I think one of them's 270 or 240 or something. I can't remember what it said in the data sheet. Regardless, it's not exactly what you would want, but you could probably show most things. Maybe you could use it for a compass display if your prop or your escape room or maybe a stage play needed a compass to swing around wildly out of control or under your control. I don't know. What other applications do you think you could put something like this to? And it's a neat idea. I'd never seen that form factor before. I don't know. Automotive guys, have you seen these in dashboards of cars? I don't know that I have, but it's been a while since I've been behind a dashboard. Everything was analog way back then. Regardless, I thought it was just a fun little thing to play with. Yeah, I guess I don't have much more to say about it. Questions and comments down below as usual. I'll put links to stuff down there as well. And I will talk to you later.